Hi, my name is Justin Sears. I'm Product Marketing Manager at Hortonworks. We're here for a brief product tour of Apache Hadoop 2. In this video, you'll learn about changes to Hdfs 2 that have improved Hadoop's core stability. I'm joined here today by two people, Arun Murthy, one of the original architects on Hadoop. Welcome, Arun.
Thank you. Glad to be here.
Arun was on the team that started working on Hadoop in the beginning, so he's been working on Hadoop for about 8 years. He's also one of the co-founders of Hortonworks, and more recently, Arun wrote the Apache Software Foundation JIRA ticket, MapReduce 279, that contained the core idea for Yarn, which is part of the recent release of Hadoop 2. I'm also joined by Rohit Bakshi, who's a product manager at Hortonworks. Rohit is responsible for Yarn, Hdfs, high availability, disaster recovery, and he also manages our relationship with Microsoft. Welcome.
Great to be here. Thanks.
I know that with Hadoop 2, there's also been changes made to Hdfs.
Absolutely.
And talking about fault tolerance and high availability, what are some of the changes that users can benefit from now because of, or what are some of the benefits from those changes? Let's talk about stability.
Absolutely. So we're talking about this one platform, right? One HTTP platform that serves the entire enterprise. You store a lot of your information. And to power that, you need to have absolute faith in your data storage capabilities, right? Absolute faith that data won't be corrupted. It'll be available to you whenever you need it. And so thinking about through a few different scenarios, right? When enterprises are running a cluster at scale, lots of things could go wrong. Hardware could fail, nodes could die, network could get lost in certain parts of the data center, certain parts of the cluster. And so Hdfs is being constructed to be a very scalable and reliable at scale system. And so some of the work that we did with the community in Hdfs 2 is to bring high availability solution to HTTP and Hdfs 2. And that high availability solution is basically where we already had in Hdfs the ability where if any data node were to die, any of the slave nodes were to lose power or network were to die, the system would be resilient to that. The system would keep going because data was replicated. With Hdfs, you have master nodes as well. And with Hdfs 2, we brought the ability where, built into the HTTP framework, you now have an active, warm, standby solution for high availability. So if any of the master nodes, the name nodes, were to die, the system would be able to automatically detect that failure and automatically fail over to a warm standby.
And that's what's known as name node HA.
That's what's known as name node HA in Hdfs 2.
So then it falls over to the other node that's on standby, and then continue from there. What happens?
Sure, and so that other node is, we call it a warm standby. And it's warm because it's live, and it's accepting state, and it has a knowledge of all the data that's stored in Hdfs. So that failover time from when, let's say, the active were to fail and it goes to the warm failover is a very short time. And in that moment of time, all your running jobs, so running read-write access, running MapReduce jobs, Hive jobs, all will be resilient to that failover event. And so we kind of look at this and we test and certify this and think of it as a full stack. So we think of, the HTTP is a bunch of different components with Hdfs on the bottom, Yarn and MapReduce in the middle, and then Hive, Pig, Tay, Storm, all these different applications on top of it, right? HBase as well, which is always online. And so any failure in Hdfs, we test and make sure that that failure doesn't cause a problem in any of the higher level processing frameworks. They'll all pause and wait until the next name node comes online. And so that's how we kind of give almost continuous availability in Hdfs to processing and data reads and writes.
And that's, I imagine, Arun, that's a key promise you need to make to an enterprise. If we're talking about you can run more and more applications and everyone's piling on that, if the underlying data layer has any problems, then you have more people that are upset by not being able to get access to that data.
And the same requirements stay for Yarn itself. We're definitely working on using the same mechanism we built into Hdfs, using Zookeeper and so on. We're doing the same thing to do high availability for the resource manager itself, right? And step 2, we continue to work through use cases like rolling upgrades for both Hdfs and Yarn. So the key part is we've got to stay very, very principled, and anything we do, in one part of the stack has to be done across the stack because, as Rohit mentioned, the enterprise just doesn't see core Hadoop. It sees a full stack, whether it's Hadoop and Hive and Uzi and Hdfs and so on. So anything we do has to percolate all the way up to stack. because it's not useful to say just one component is available. We have to do it across the stack. So at the end of the day, the business process that you're running will touch a large number of pieces in the stack, and all of them have to be available in a continuous fashion, so that your business doesn't suffer any downtime or outage.
We think of service disruption and service degradation, right? Yeah. There should never be a service disruption. If you have a Hadoop cluster, you deploy in production, you're running jobs on it, you expect certain SLAs, those should never be degraded or disrupted. And that's where a lot of this core stability that we talk about is being put in place. Rolling upgrades, high availability. We introduced snapshots in HTTP2.
What does that mean? Because I hear the term, but I don't quite know exactly what that means.
So what snapshots do is it handles a slightly different failure scenario. A scenario where you have a user or an application that's gone in and done something to the data, that's either deleted it or changed it in a way where the processing now cannot move forward. So snapshots are points in time recovery moments. So it's basically saying, I'm going to snapshot this data set. Let's say you have warehousing table in Hive. That data is stored in Hdfs. You create a snapshot of it so that as that data changes, you always know that you can go back to a point in time state of that data, let's say 2 days ago. And so if you run some processing and you had an errant job that did something that lost certain key client data in certain rows, you can always roll back to a prior moment of time. So we have snapshotting built in for Hdfs and for HBase on top of Hdfs. So your core storage systems in the HTTP platform give you backup solutions, give you point-in-time recovery solutions. So couple that with high availability, and now you have this very reliant and tolerant and resilient system to different failure scenarios.
What's coming next to advance even some of these improvements more?
I can take a first shot at it. In terms of Yarn, obviously I think we're comfortable in our skin at this point to say that Yarn is by far the best environment in which you run applications like batch with ETL, with MapReduce, or event processing with Storm, or interactive queries with Hive and These. If you sort of look ahead in the next 12 to 24 months, as people get comfortable with it, what we're beginning to see is saying, okay, this is great. We have this awesome platform. Now I want to manage more than just point-in-time applications. I want to manage something like Hdfs, which runs forever. I want to manage something like Accumulo, which runs forever. So there's this sort of emerging need, I would say, emerging requirement to support services, long-running services, really, really well. So a large part of our efforts in the next, I would say 3 to 6 months will be to make sure that Yarn continues to be a great platform for applications, but also continues to be sort of evolves into becoming a really good platform running long-running services. Now, what does that entail? It entails some interesting requirements in terms of security. How do you manage, if you have an application which basically runs forever, how do you manage its identity? How do you manage its authentication and so on is an interesting one. How do you manage things like, basic things like logs is an important one. I mean, as you run things forever, how do you make sure that there's always diagnosability and debuggability for an application, for a service that runs forever?
What metrics to surface,
exactly.
What do people care about, when to refresh it? Yeah, that makes sense.
Yeah. So a lot of these requirements are interesting. We've been fortunate enough to solve some of them with 2.0 itself, but there's definitely more coming in, HTTP 2.1.
Rohit,
what are some of the things on the roadmap for 2.1 with regards to Yarn and Hdfs?
So when I think about the roadmap, and I think about 2014, I think about 3 different pillars. So one is reliability, absolutely core pillar of Hdfs and Yarn. And so we'll continue on that journey with Resource Manager HA. We have automated failover and resiliency of the entire stack to a failure event for the Resource Manager. As well as with Nfs gateway high availability. So the ability for an Nfs client to withstand any kind of failure with an HTTP and keep having read and write access to the cluster. The other pillar is multi-tenancy, and we touched a bit on that in terms of what functionality exists in 2.0, and we continue that story. So multi-tenancy in a long-running service, what does that mean? How does something like Storm that's a topology running for a month, how does it keep resources? How does it share resources with other batch applications? Those are interesting problems that we're looking forward to tackling. How do you enable organizations to manage your scheduler and your quotas and your access to data at different levels of the framework, right? How do you deal with manageability in a system where there's hundreds of users, there's 20 different groups, all fighting for the same set of resources? So there's some interesting challenges that we're looking to work on, preemption, to bring those kind of features into HTTP 2.x over time.
And what about something like how are there other ways to access Hdfs? Is that something that you guys are thinking about?
Absolutely. So you know, when we look at access patterns, right, we have RPC applications can write through RPC mechanisms, can access data in HDFS. You have REST-based access patterns through web HDFS. You can go over REST and talk to HDFS, write data, read data. And recently with HTTP 1.3 and 2.0, we introduced Nfs Based Access.
Right, yeah.
And this is really exciting because we were talking to customers who said, I want to start working with HDFS and Hadoop. I want to start writing data into this distributed cluster that I'm really excited about. But I have all these applications that don't talk custom APIs, that don't talk over REST. They just write to disk. And I don't want to change those applications. And so we looked at that and we said, well, if we introduce NFS, which is an enterprise standard, right? Everyone knows, all applications, all enterprises know how to deal with using NFS to write data and load data into a system, into a remote file system. And so that was an investment we made in 2013. It's really paying off because it's allowing us to work with customers who don't want to change their existing applications. And now those existing applications can write into HDFS at scale. And so once that data is in, they can do all kinds of interesting analytics on top of it that they couldn't do when they were writing to just file systems, regular file systems before. And so it's important, you know, as an enterprise software vendor, to think about those enterprise standard integration points and enable them. NFS is a great way that we've got closer with those integration points.
Excellent. Anything to add to that, Amir?
In terms of roadmap, we continue to see more and more feature requests as from people who use it, particularly around operability and SLAs. One of the interesting things that's come up recently is we've started to hear about people who want what I call as not capacity planning, but point-in-time capacity planning. They say at 3 in the morning, I've got this really important data set which is coming through a partner. I want to make sure that it has a really tight SLA, right? So in those scenarios, I absolutely want to reserve some portion of the capacity in the cluster for a very short window in time, an hour or two, right? That's my SLA. So features like that, as Yarn becomes more and more general purpose and tackles on more and more use cases, those are the kind of features we're starting to see. And that's exciting because it means that people are moving beyond just the use cases they were aware of with MapReduce. It means that they really understand sort of new requirements. And new requirements show up because of the fact that they already get Yarn and they're trying to leverage it in a more in an even more efficient manner, if you will. So it's really exciting. I feel like 2014 will be a year where we can focus on a lot of the net new features. I think 2013 was sort of, let's make sure we operationalize, let's make sure we deploy at scale and get feedback. And now that we've done that and we've passed that first couple of hurdles. And
that feedback's coming in from multiple enterprises.
Absolutely. Yeah. An example of that is we have new applications and new ways of interacting with data coming because of Yarn, right? And one of the requirements of drawing is latency of access. And when you have an application that's competing for the same set of resources, the system needs to become smarter about how it rations resources to give that application. So for example, an example is heterogeneous storage, where in a cluster, I have different types of hardware, right? I have solid state disks, I have SATA hard drives, I have external hooked up file systems. All these different systems, all these different data storage techniques can live in the same data center, in the same cluster. And so an application like HBase that has a very low latency read and write requirement for data can tell HDFS, hey, I want to store you to store my data in SSDs. Or I want to, or in different tiers of the storage environment. Hive and Thais, Hive on Thais will want access to certain tables very quickly. So it'll tell the HDFS, why don't you load this into memory for you? Why don't you cache this in memory so I have very quick access to this specific data set? And so now you have the ability to incorporate, think of bottoms up maybe, different types of hardware resources, multiple network cards, different types of storage, memory. You can now utilize that and provide those as differentiated resources to applications living on top of your operating system. So tying those two things together is really where the future of Hadoop as an operating system goes as well. It's very exciting, and we will make progress on that in 2014.
Arun and Rohit, thank you so much for spending the time talking about Yarn and Hdfs and Hadoop 2. Very exciting, and I can tell you guys are excited about it. And I want to thank you for joining us. You can follow all of the upcoming improvements that we mentioned today by going to our website, hortonworks.com. We have pages on Yarn, Hdfs, and we also have our blog there, and we will be updating you about improvements, Yarn, HFS, and Core Hadoop throughout on our blog. And then finally, follow us on Twitter. That's where you can get minute-by-minute alerts on anything that posts to our blog, and so you'll know about any changes that we're making to Hadoop or Hortonworks as soon as we make them. Thank you for joining us.